Hello class, welcome to Geometry Lesson 9.4, which is all about parabolas in the coordinate plane. By the end of this lesson, you should be able to use equations and graphs of parabolas to solve problems. So as I have mentioned in class Lesson 9.4, I'm going to do kind of like a light version of it where I take some of the things out because we just don't have the time to go that in depth with the material. You'll cover some of the more in-depth knowledge with this later on in Algebra 2 or pre-calc classes. So we're going to do kind of a light version of parabolas in the coordinate plane. All right, so let's first kind of explore what a parabola is. Some of you guys, when I say parabola, maybe remember from Algebra 1 last year that it was something that looked like this, where it either opened up or down, and it was a curved line, right? So that's a parabola, and we're going to talk about some specific characteristics of a parabola today. So if we look at this first example, and it says, what is the set of points that are equidistant, so remember that means equal distance, from the graph of the equation y equals -2 and the point 0, 2. So I already plotted the graph or the equation and the point. So they're highlighted in orange over there. And let's just figure out some points that would be the same distance from both of them. So if I'm looking for something that's the same distance from the orange dot as the orange line, I would choose something right in the middle, right? That's what we're looking for. So in that case, that would be that green dot that I just added, right? It's 1, 2 units away that way, 1, 2 units away from the line. So I found one point that's perfectly equal distance between the point and the line. Now some other examples could be if I were to go all the way out to, let's see, -4. If I go like this, that's 4 units away from the dot, and it's 4 units away from the line. So that tells me that this point is the same distance from the dot as the line. If I were to go the other side, it's 4 units away and 4 units away again. So I now have multiple things that are the same. I could also go up to, if I went over to -8, 8, I already did a little pre-work with this, -8, 8, and then 8, 8. Those are the same distance because if I go this diagonal, if I were to find the square root, or sorry, if I were to use the distance formula between 8, 8 and the point 0, 2, I end up with a distance of 10 units. And if I count from the dot to the line, that's also 10 units. So I know that those spots are also equal distance. So if I connect all of those, I'm sorry, I just realized I'm saying so a lot. If I always do that, I am so sorry. Oh, I did it again. Moving on, I will try to avoid that word. As you can see, those dots end up forming a parabola, and all of the spots, all of the dots on the parabola are actually equal distance from that point 0, 2 and the line y equals -2. And those that point and the line have very specific names. So what you should have gotten out of this example was that there is a point and a line that are equidistant from a parabola, and that goes for any parabola. That's all I wanted you to learn from that. Now, let's talk about some vocab. So we've already talked about parabolas a little bit, and as it's saying, a parabola is the set of all of the points in a plane that are the same distance from a fixed point f, okay? And that point f, so in the last example, we just called it point 0, 2. That fixed point has a specific name. It's called the focus, and you're going to hear this a lot in today's lesson as well as in the homework. So make sure you understand what the focus is. And so that's the name for the dot, and our line also has a specific name, and that name for the line is directrix. Directrix. You're going to hear me stumble on that word because that word is difficult for me to say, but I will do my best. Okay, so we have a parabola is the set of all the points in a plane that are the same distant or equidistant from the fixed point, F, the focus, and the line, D, the directrix. Okay, now let's take a look at what an equation for a parabola looks like. There's two different equations that we're going to use today. One is when the vertex is at the origin, and they will tell you the vertex is at the origin. And the other is when we have a vertex with the center, or not with the center, the vertex at HK. The HK you'll be familiar with from 9-3 because HK was the center of our circle. So HK is the vertex on our parabola. You're going to want to take a screenshot of these two equations and have them handy for yourself. So that way when you are doing the assignment, you have something to reference. Example 2, write the equation of a parabola. What equation represents the parabola with focus 5, 5 and directrix y equals 1? The first thing we are going to do, since we have the focus, we have the directrix, the first thing you do is you plot those points. Once you've plotted, actually not points, once you've plotted the point and the line, so in this case they are right here, you want to figure what is exactly halfway between them. And in this case, that would be this blue dot right here, which is 5, 3. Don't know why that did green, did not change my color. Let's try again. 5, 3. Okay, so that is our vertex. Our vertex is what is located exactly halfway between our focus and our directrix. Now we have the vertex. And what we can figure out from that is we can figure out how far the directrix and the focus are from the vertex. In this case, they're 1, 2 units away, 1, 2 units away. So I know it's perfectly in the middle. But what I'm going to do is I'm going to state that distance by saying P equals 2. And the reason that's important is because if we go back to the equation, you'll see that there's a P located in the formulas for you to use. That P represents the distance between the directrix and the vertex, or the distance between the focus and the vertex. Both of them should be the same number though. Alright, once you've graphed it, the way you can write an equation is, I'm just going to extend that to make it a little easier. The way you can write the equation is you use the vertex as your HK. So I'm going to replace H with 5 and K with 3, which is done in this step. And they also replaced P with 2 because the directrix and the focus are 2 units away from the vertex. Then all they do is simplify a little bit. They say y equals, notice they moved this 3 over to the other side, so y was by itself. You are going to have to do that on today's assignment as well. My smartboard is freaking out as I'm trying to erase. So move the -3 over, so y is by itself. Multiply 4 times whatever your p value is. In this case, we said it was 2. I now have 1/8, and then I have x minus 5 squared plus 3. You do not have to FOIL that. You can leave that just like it is, okay? So in today's assignment, you're going to do things like that. This is an example of a problem that you're going to have in your, or on your assignment today. I want you to try it on your own, and then if you can't get it, that's okay. I'll walk you through how to do it, and we will figure this out, okay? I promise. Good luck. Okay, for this problem, hopefully you ended up with y equals 1/12 times the quantity of x plus 1 squared plus 1. The way I got that answer was I started by drawing my line, y equals -2, and plotting my focus, -1, 4, and figuring out that vertically they're 6 units apart. That means the halfway point, or my p-value, is going to be 3, because that's how many units the vertex is from the focus as well as the directrix. So I'm going to use 3 for my p-value. And I figured out that my vertex is at -1, +1, because that's that midpoint between the focus and directrix. Next, what I did was I took my general formula that was on the theorem that I told you to, or not the theorem, but the slide that I told you to take a screenshot of. So we have y minus k equals 1 over 4p times the quantity of x minus h squared. So what I did was I plugged in my vertex. I said y minus 1 equals 1 over 4 times 3. That's the distance between focus or the directrix to the vertex, times x plus, and that should also be blue just to show you, x plus 1, because it was a -1. So then if I move that 1 over from the y side, I end up with y equals 1 over, and then 4 times 3 is 12, x plus 1 squared, and I have that 1 that got moved right there. And then just the simplified answer, I just wrote it nice at the bottom. Y equals 1/12 times the quantity of x plus 1 squared plus 1. So in this assignment, you're going to have to do this process a lot. So if you have questions about it, please be sure to reach out for some help. And this is just kind of, the concept summary for this lesson. I know this lesson has some scary vocab, but once you get the hang of it, I promise it's not so bad, okay? If you have questions, though, reach out for help. Have a great day.